Problem 7. This is a nice little throwback. Before I even read it, I'm just going to pay respect to the fact that I see a nice small little triangle there, and I see an overlapping larger triangle there. And I'm going to remember whenever I see this kind of setup, whenever I see overlapping triangles, what should come to mind is similar triangles. And what should come to mind from similar triangles is sides are proportional. And what that really means is sides are in equal ratios, meaning that ratio is the scale factor. I know we've kind of said this a bunch of different ways now, but some dilation happened. And when a dilation happens, it produces similar figures. And it's just a matter of, well, how? But great, all these things come to mind. I'm in that similar mode, and all this stuff I have access to. Let's see what they're asking me to do. So, given triangle MRO, that's the big blue one, with trapezoid PTRO, that's just them trying to throw you off. They're just trying to show you that, hey, yeah, there's also a trapezoid in here. But you want to actually avoid that. You don't even want to think about that trapezoid. You want to think about the thing they didn't talk about. You want to think about triangle MTP, that small red triangle. So they're going to tell me 3 pieces of information, which already looks like it's in our diagram. MR is 2, and then they're going to tell me, MP is 2. MR is 9. And notice MR is the top of the triangle all the way to the bottom. And that's what they're really showing me here. So I'm going to color that blue because it belongs to the blue triangle. And then they're telling me this PO thing. PO doesn't belong to any triangle. It actually belongs to that trapezoid. PO is 4. And what they want me to find is the length of TR. Ooh, that other green piece. This thing right here. They don't want me to figure out what that is. There's a couple different ways you can do that, but I think if we set it up like this, it's pretty clear that 4 from like the left side corresponds to x on the right side. So I can make a fraction. I could do 4 over its corresponding piece, x. And since we're talking about similar triangles, I'm allowed to make a proportion. I'm allowed to say, yo, that thing is equal to some other ratio formed in a very similar way. And immediately you want to go, oh, hey, it's going to be 2 over whatever that is. And we don't know what that is. So we could call it y, but now we got 2 variables and we can't solve that. And I think you should be resilient enough and say, okay, 2 is not going to work for me. I can't do that. And you should really be looking in at that 9. And you should be saying, okay, well, I have the whole entire right side. And you should ask yourself, do I have the whole entire left side? Do I know this entire piece? And the fact of the matter is you do. This entire piece is 2 plus 4. It is 6. So you could do something similar. Now you can say, hey, this left side of that bigger triangle is 6, and the corresponding right side is 9. And now you've got an accurate proportion you can solve. And we solve proportions by cross multiplying. So this is going to be 6 times x, which is 6x. This is going to be 4 times 9. I just encourage you to take out your calculator and do 4 times 9. Better safe than sorry, and that's 36. We're going to divide both sides by 6, and I can tell you x equals 6. But hey, might as well check. 36 divided by 6. And I'm just going to verify, hey, was x what I was trying to find? And yes, x is the length of TR. You can say TR equals 6. And be done with this problem. I'm going to stop the video here. If you solved it a different way, you used a different proportion, or maybe you used the scale factor, raise a hand, share it with me, show it. We'll show it off in front of the class. This is just one method, and it was the method that came to my mind.